Hi, welcome back to the breadboard. This is part 2 of a two-part programming 101 for NodeRed on the Raspberry Pi, which is including integrating with an Arduino Uno, some servos, analog inputs, LED driving, and switches. So in the first video, we had an overview of NodeRed, what it can do, some of the controls, and I showed you an example of an application that I'd already written. That was the first ever application I wrote, and it didn't actually take me too long to do at all. In this video, what I've done is I've deleted all that application, and I'm effectively going to recreate all of it with the exception of the MQTT part, which I think is a little more advanced for 101, but it was part of that initial app that I was playing with. Hope you enjoy this. I'm going into a lot of detail, so it is probably close to 40 minutes in duration. The whole thing originally was over an hour, so I broke it down into the overview section at the beginning, part 1, and the effectively what you might call the hardcore programming bit in part 2. Now, this is not aimed at experienced programmers or anything else like that. The whole point of this is to allow a beginner to be able to get used to and start programming a Raspberry Pi and get actual things happening. So all you need is a Raspberry Pi, maybe a breadboard, and a few miscellaneous components that you either may already have, like LEDs or something, or the kind of things anyway that you would get in a typical starter kit for either an Arduino Uno or a Raspberry Pi for doing I/O and everything. Anyway, the requirements are not high, as I said, and the expected programming experience is virtually zero. You need to know your way around the PC, and you need to know how to upload a sketch to the Arduino Uno, although you could skip that bit if you wanted to, and connect up some LEDs and things with jumper wires and things onto the Raspberry Pi. But that's pretty much it. So, as I say, aimed at beginners, but it might be of interest to more advanced people as well if you've never really been close to NodeRed, just to get you up to speed. Total viewing time for part 1 and 2 is, as I say, just a little bit over an hour. So let's get right into it, and I hope you enjoy the ride. To open NodeRed, once you've done all the installs, by the way, you just type in the IP address or the name of the Pi or whatever, :1880, and that's it, and press enter, and it should load up with this particular page here. Now, the first thing, as I said before, is let's get that pin 13 blinker working. And as you can see on the screen grab of Arduino, pin 13 is not blinking at all. It's just sitting there on because that happened to be the last state before we killed the code in the Raspberry Pi. So let's now add the piece of code. So the way that you do this, if I go back to the web page that was running, okay, so this page I'm going to include the link in it anyway in the description, which is nodered.org/hardware-arduino.html. So the first thing it tells you to do is go into the NodeRed folder and then run the npm install NodeRed node Arduino, which we've just done. The next thing is for this blink, I'm just going to copy this code here. All right, you can, once it's in, you can modify it whatever you like with it, and then you go to your web page. All right, in which case ours is on the Pi 2-1, and you simply, this little menu block here, you bring it down, you say import via clipboard, click it, just paste that, just literally just control V into it or right click and paste, and it puts it into this text area. Click OK, and it instantly creates that node for you. So this is showing a way that you can actually provide programs to people of pre-configured nodes if you wanted to. But anyway, you drop that in, and that's done. Now, this now is very familiar to what we had before. We've got the inject node. It's a repeating at an interval. The next one is the function, as I said, that all it does is invert the message context level every time you go and trigger it from this half-second tick. And then the Arduino node is pin 13, Arduino, and it's a digital output, and that's really all it's having to tell it what to do. So this piece here is the one that will actually then talk through the serial port to Firmata and make that pin do its thing. So in order to test this now just to show you something here, these two let me just minimize that one because that's just going to confuse things. So this node here is the UI of the Pi 2-1, and because there are no UI components here, nothing should show up on this one. So we're just going to deploy that now. As soon as I say OK, confirm the deployment, successfully deployed, and now you can see the light blinking on and off on the Arduino, which is really, really cool. Okay. So that shows that that is deployed and is now automatically running. And it actually says here, there's a little message here that says it's connected as well, which confirms that it's found the Arduino and connected to the Firmata instances running on it. So let's look at adding the LED that's on the Raspberry Pi directly connected to it. And I've actually connected this to the Raspberry Pi. Let me just check what pin I'm using. All right, just a quick Google for Raspberry Pi 2 pins, and the ones I'm using GPIO 4 for the big LED. I don't have any resistors or anything else. I'm just using the output into the LED and then down to ground. So the output has a limited amount of current. This is literally just for testing. If I was making this into a product, I would have a resistor and a driver and everything else. I don't mind that the LED is not too bright in this instance. It's just for demonstration purposes. The push button switch is connected to pin 11 GPIO 17 rather than GPIO 27. So that's the connections that we're using for the directly attached hardware to the Raspberry Pi. Now let's go back to the programming environment. So the first thing we'll build here is just simply a switch and connect it to the LED on the GPIO. So just scroll down till you find the UI components. So we're going to drag a switch onto the screen. Now we have to configure the switch. Now one of the things that tells you the switch controller is not configured yet is you get this little red triangle on it. So if you just double click it, right? If you're doing this the first time in, you will not have home here, right? These are for various tabs. So if it doesn't exist, it'll be basically saying add a new UI tab, and you just click this pencil mark here and you would create one. Rename that and call it dimmer control. And you'll see what will happen in a moment. So we're going to create this slightly differently just so you know I'm not cheating. The icon is I'm just going to leave that alone, and it's just going to leave that alone. And that's pretty much it. The sheet I'm going to leave alone as well. So we'll just say add. So now we're in a tab called dimmer. The name is on. Let's just change the name to say on off. The topic, we don't have one. The group, we're just going to call dimmer, because this will actually put, when you put groups on things, they will put boxes around the sections. They will isolate one set of controls from another one and things. So the on value we need, because we're going to be driving a pin, we need it to be ones and zeros, not trues and falses. So on is 1 and off is going to be 0, and you just put that in, say OK, and now you see the little red triangle has gone away to say that it's been configured properly. Now we need an output. We need to be able to connect to the pin of the Raspberry Pi. So we come up to the Raspberry Pi section and we go Raspberry Pi GPIO right here, and we drag one of those on the screen. And this one, we need to tell it that it's a Raspberry Pi and what pin we're using. Now, as I said, this pin physical pin, to go back to this a second, it's GPIO 4, it's physical pin 7. So we do this drop down and we physical pin 7, you can see it says BCM4. It's calling it GPIO 7 because, I mean, there's a number of different places have different naming conventions for the pins on Raspberry Pis. The thing to remember here is that the very left-hand number is the physical pin number. And then, it's confirming it to say that it's the controller output 4, so that I know that this one happens to be the correct one. I want it as an output digital for now, and I want to initialize its state to a low, which would be off, and I'm going to call this, for now I'm going to call it LED. All right, we say OK. Now this one doesn't have a group or anything because it doesn't show up as a UI component on a screen. Now individually these don't do anything because they're not connected, but to connect them all you do is put your mouse over the one, you get a little X, so it'll light up with red there or orange. Drag a line, drop it on the other one, and that's pretty much it. So now if we deploy this, what you will see on here is that control should show up. So let's just hit deploy. We'll confirm the deployment. That successfully did it. So over here now, in a moment, so now the dimmer has come up as a control, and see we've got on-off, which is all we programmed into it. And if you look at the NodeRed, now that it's deployed, it's actually saying it's okay, and you've got this on-off here. All right, and it doesn't do anything, but watch when I now click this switch. All right, you can see on just right here, it's saying 0, which is what was the initial. It said OK initially to say it was correct. Now when I click it, you can see it's going 1 and 0. Now the question is, what's happening on the Raspberry Pi? So let's just bring the Raspberry Pi into view. Here is the big LED, and now you can see I'm clicking the button, and you can see the light going on and off nicely. So that's all it took to actually now get a Raspberry Pi connected to some GPIO and getting it to turn on and off. But the nice thing is you're doing this with a web page. So if I bring up my smartphone, and I'm going to have to put this under the camera to show you, and it's automatically updated now to that same screen. If I push this button, you can see I can also control it from there. So there's nothing special, but it's created a completely nice web page that's HTML compliant, that works happily on pretty much any smartphone or smart device that I've tried so far. It is just a web page, so it should work, of course. And it's letting me control it from there too. And I didn't really do anything else except bring it up and start hitting the button. And the nice thing is, if you notice on the screen, as I'm hitting the button on the smartphone, the button on the screen on the web page on my actual PC is also changing to reflect that value. All right, so that's cool. We've got a light working now. You can remotely control it. So if you expose this over the internet to your smart device, you could turn your light on and off or whatever was connected to that LED pin. You could control it nicely from pretty much anywhere, in the house, out of the house, doesn't matter. Cool. So let's continue. We made that into an LED. Now obviously instead of an LED you could have a relay or something else connected as well through a suitable driver. But now let's make this into a dimmer, because we called the group dimmer and everything else. And usually with a dimmer you want to have a slider. So let's go back down to the UI components, and we'll pick a slider control right here. We'll just drag that on the screen. You notice, by the way, you get help all the time when you click in these objects. If I hover over them, it'll come up with a tooltip telling you exactly what it does and everything. Now, slider has a red mark on it because it's not configured. We go in here. Yeah, we're not going to give it a topic. We're going to call it dimmer. When you create these groups, if you look up here, see that group name now? That shows up here. That's what that is. This is the tab that I named when I renamed the tab at the beginning. And this is the dimmer control. You can see here it says tab dimmer. All right. So I'm adding another control, and I'm putting it in the same group dimmer. So this is the whole tab, and then a subgroup. It's a slider. Minimum value 0. We know the slider needs to go from 0 to 100 output because that's what the dimmer wants. The PWM output of the Raspberry Pi wants for its control. So we say OK for that. And now we can literally just drag that, drop it on there, and now both controls are driving it to the LED. Now the LED right now is set to be a digital output, so it won't work if I just deploy this as it is right now. I'm fully connected through Wi-Fi to both of these components, so occasionally I get a bit of, I've got so much gear running around, occasionally I get a little dropout from my network connection. So you can see now that that's deployed. There's my slider now. But if you look at what the LED is doing on the actual Raspberry Pi, it's probably the minute I start moving this from, it's going to probably go up to immediately come full on, because right now it's set for digital, so it wants 0 or 1, and anything bigger than 1 is just going to be taken as 1, so it's not acting as a dimmer yet, right? So we need to fix that, and the way we fix that is this. You go back to your LED control output, which is the GPIO output for the Raspberry Pi. Just go back in there, change that from a digital output to a PWM output. We know it's already set as an output, and that's fine. You just ignore that error. And that's pretty much it. Now say OK. Because it's PWM, it's now telling you here it wants between 0 and 100, which is what we are outputting. And we'll deploy that, say confirm, and that's confirmed. Now, when we play with the control, let's just start the video camera again so we can see. I can still turn it on and off with the switch. Okay, this is showing up another thing we have to do. If I take the slide, just for now, let's just take the slider, and you can see now it's working as a dimmer. Nice. But the switch now is having almost no effect. It's coming on very, very dim, and let's just have a think about that for a second. Why is that? If you guessed that the on-off control, i.e. the switch, is only outputting a 0 and 1 instead of a 0 to 100, you would have guessed correctly. If you couldn't figure it out, that's okay. You just, a lot of you were just learning. So let's go back to the control for the switch here, the on-off switch, and we're just going to change this to say, instead of 0 for off and 1 for on, we're going to say send out 100 when you get turned on. All right, and then we're just going to deploy that, say OK. And we successfully deployed, and now when I use the button for the dimmer, I'm going to be outputting different values. Right, now the LED comes on full brightness or off. And you'll notice over here as well, it's now saying 100 because that's what the on-off switch is now outputting to the LED. All right, so on-off is working fine. Now, if I take the slider now, you'll see that that value over here is actually reflecting what the slider is outputting. And you'll see that the LED is truly dimming on and off. Now, if I'm in the middle and I tell it off, it goes completely off because it sends a 0, and then I can go on. So that's a handy little control. If you have a light somewhere and you want to be able to dim it, but you also want to be able to quickly turn it on and off, you now have it. Nice, easy, straight to the point, done. Okay, so that's bit of fun out of the way with the dimmer control on the Raspberry Pi. Now let's make something else happen. For instance, when I push a button going onto an input of the Raspberry Pi, I want it to send an email. Now that email could equally be telling you that the front door's open, that somebody's pressed a button in a factory. It could be an alarm system. It could be anything else. All I'm using is the button to trigger an event going into the Raspberry Pi to signal that something has happened. That could be a motion detector. It could be all sorts of different things. So the first thing we need to do, obviously, is get a Raspberry Pi input in this case. Let's just take the Raspberry Pi GPIO inputs, drop one of those on the screen, and we need to configure this. Now in this case, we're using 17 for the input on this one. So specify pin 17. Now in this case, because it's an input, we're going to say use a pull-up resistor on it. That way we don't have to put one on our circuit board. And we'll initialize the state of the pin on deployment on restart, so that when it boots up, all of this is already done. And we're going to call this, let's just call it alarm. All right. So this has no UI component, so it doesn't have a group or anything else. Now, we're going to want to send an email to somewhere. So if you look in here, one of the things that is under social is email out. So let's just bring that on the screen. All right, and we just join the two up. And now if we go into the configuration of email, it wants who you're going to send it to. So I'm going to put my address, so peter@thebreadboard.ca. The server in my case is smtp out.secure server.net. User ID peter@thebreadboard.ca. No, I'm not going to tell you my password. And we'll call the node alarm email or something like that. So that's all you need to do to configure the email. You don't need a local mail server running or anything else. If you've already got a mail account on the internet and you can use Outlook or whatever to it, then you can simply configure this and it will send the emails to it. So let's just say OK, and it should, if Google pops up like this, you don't need to remember it there. It's already in here. And that's it for the alarm. Now, maybe I want to put some indicator on my web page for this. So let's just see if there's anything on the UI that can also maybe give us some indication that something is happening. So we'll draw a line from there to text as well. We'll go into text. So it's called dimmer. Nope, call this one. We'll do a new one for this. I'll call it alarm. And add that. So email alarm, and the group will call it alarm. That way it will put it in its own group. And template will leave as message payload, I think. I'm not sure how to configure that right now, but that should be enough. Now, when we deploy this, we should get another block show up on here. So the send failed for the email for some reason. I'll have to look at that in a second. Because the button is not pressed, it's showing a 1 for the alarm state. So let's just ignore the fact that the email is not working right now, and I'm just going to press the button. If you keep an eye on the screen, I'll embed these next to each other, and I press the button. You'll see there it's going to 0, it's going to 1. Going to 0 is going to 1. So you can see the email right now on the NodeRed is saying it's failing. So we have to have a quick look at why that is. Okay, figured it out. It was actually relatively straightforward. In my email, it attaches to your local email if you're running it. And when it went out to the server, I was trying to put my user ID in as peter@thebreadboard.ca, and what I should have done is put it in as peter@oaksclan.com. I need to look a little bit more into it because I should be able to use that as well, but I'm trying to send it to peter@thebreadboard.ca, so I'm sending it from my oaksclan.com account. That's all it was. Anyway, now it's working fine, so I've just hit the deploy button and it's gone out. So you can see here I've got my alarm condition as 1 and everything's sitting status quo. And you can see up, if I go to my dimmer and go to the alarm tab, you can see it's sitting as 1. Now, if I put the screen on for the Raspberry Pi and everything, you can see I'm going to just go press the button, and at the same time, you will see the fact that it will say that the value has changed, and also it will tell me that it's going to send an email. So if you look on the email part of this at the same time here, just underneath it, it's going to tell you that it's sending and then sent. So when I press the button, sending, and that's it. And you can see the value on the alarm slightly to the left is sitting at 0, and also on the page is sitting at 0. Let go of the button, it saw the state change, and it sent an email again to my breadboard account. Now if I bring up my email system on here and go to the breadboard, there is the email that was sent. In fact, there's a whole bunch of them while I was playing with. And you can see it just sent the 1 and sent the 0 and the 1 and that's the email part. You can see how easy that is to send once you got it configured right. Sorry about that, simple mistake. And so that little node now runs completely independently of this one. So you've got your slider sitting here under the dimmer, and I can actually make that LED still dim nicely. The alarming for the email just by pushing the button. You can see that working nicely. So that's everything now deployed. We have the Raspberry Pi driven Arduino output pin 13 toggling away. Let me just put the camera on so you can see that pin 13 is blinking away there nicely. We have the input to the dimmer where we can turn the LED on or off, and we can also use the slider to vary the intensity quite nicely. That works a treat. That's these two controls here, and then we have the alarm one, which can send an email, and also if I switch the alarm tab here, will reflect the value on the web page too. So you can see we have sending, and then as soon as it comes back, I'll let go. I'll let go now anyway, doesn't matter. Yeah, a little networky problem there. I don't have any debouncing or anything like that on that button either, so it's just sitting in a breadboard, which would probably account for why I got all of these things being sent. But there's the email coming in from those presses. There's one of them with the 0. So you can hear it in the background bleeping away. So next we want to go and have a look at driving these servos. So we'll leave this alone. These ones here, we'll leave them on here. Just move them up a little bit. And now we want to drive the servos. I'm just going to delete the email piece here, so I'm just not spamming myself with emails when I'm powering these things on and off. Actually, I'll just disconnect. I'll just disconnect the line. That'll be the easiest way. Redeploy that. Now, servos. So, how do we drive the servos? The servos are connected to the Arduino, so we know that we want to drive through there. We want some way of changing the values between 0 and 180 for the servos. So the logical choice there from a UI perspective is, again, a slider. You could also use a numeric input if you wanted to, so maybe we'll include one of those too. But for now, we'll just use a slider. We'll drag 2 of those on because we've got 2 servos, not a switch, slider. So we'll go into the first one and we'll call it rotation for the name. Now, we don't need a topic here because we're going to drive it directly. I'm going to save the MQTT stuff for a separate video. I think this one's getting long enough already, and I'm just going to, I don't want to make it too complicated. So the group, we're going to call it Servos. And I think we'll stick this in its own tab as well, just for the hell of it. So we'll create one called Servos. And what that'll do is under here, we'll end up with an extra one called Servos. Makes it nice and easy and doesn't clutter the screen up. So we'll update. So now you can see we have dimmer, home, servos. I think I just renamed alarm. I want a new one. Oh, it was dimmer that I screwed up. I'll have to go back and fix that in a second. Let me just create one for dimmer. And we'll have to go back and make sure those controls are in it. Anyway, we don't want dimmer for this, we want servos. Rotation, don't care about the topic. We'll put it in a group called servos, so it puts a nice pretty box around it. Minimum 0 and maximum 180, because these are the values that you use to drive a servo. So that's the rotation. We'll do the same thing for position. We'll put it under the servos group tab. We'll call it position. Group servos, 0 to, again, 180. So this is all just simple configuration. And we'll say OK to that one. So now we have 2 controls that will show up on a UI in their own area. But we don't have them doing anything yet. They're just going to be there. Now, because one of them is position, we potentially could use maybe a gauge just for fun to put it to display the values. I mean, it's going to show it underneath the control anyway, but we can have some fun. So let's just go put it in the servos group, angle, servos tab group. So the value will be shown minimum, maximum 180. I'm going to say OK, and that's that connected. Now, we also want to put these now to the Arduino. So we want Arduino output, and the rotation one we put on the Arduino pin 7. Okay, so we just go in here. It's an Arduino. We want it on pin 7. And we want to tell it it's a servo. These are all built into the Firmata. And we'll call this one rotation, because that's what it is. And we'll just say OK. Oh, that control's not going to work on there. We need that control over here. This one's just simply rotation. And we just join that to that, and that's all you got to do. For position, we're going to, because it's between 0 and 180, we'll connect that to there, but we'll also have an Arduino output, which is on Arduino pin 6, and this is also a servo, and this one is position. So I'll call it position. And we'll also drag another line to that one. That's pretty much it. That's all you have to do. That should now be enough to make those servos work. We're going to have two controls show up, one called rotation, one called position. One of them has an extra display on the screen, there should be, and that should be all we need to do. So now we just say deploy, and hopefully my network's not acting up, and it'll deploy. There we go. And any second now, this should be refreshing. All right, there we go. So there's demo with the on-off and the slider that we had before. There's the alarm that shows the output currently being a 1. And then here's our new tab that we just added for servos. So let me just scroll that down a little bit. And you can see here, here's our little graph as well for position. Now, theoretically, if I just take that, you can see it's updating that graph quite nicely. And you can hear the servo changing. In fact, you'll be able to see it moving as well in the picture to reflect the angle. I know it's going in the opposite direction, but that's fine. I could just change this to be a 180 to 0 instead of 0 to 180. And then the rotational one, right now I haven't sent anything, so it's not set to a default value or anything like that. The minute I start doing anything, it's going, because it's at 0, it's going anti-clockwise, and then as I come to 90, it will stop, and then I go further past it, and I go the other direction. You can see it's quite happily working away. Right, so I've got now 3 tabs very easily added, and you saw how quickly we were able to add an Arduino servo output to this as well. So you've got PWM out, you've got servo outputs, you've got digital outputs, and you've got digital inputs. And I think with the Raspberry Pi going into the Uno and Firmata, I think on the inputs you may also have an analog one. So let's have a quick look at that. Let's just close this bit off. The one we want to look at here is reading analog inputs from the Arduino if we can. Now I have a pot here that I can add to my breadboard, and I can just do a 0 to 5 volts, which should give us 0 to 1024 value, and maybe we can connect that to another one of those graphing displays like this one here. So let's just drag an analog Arduino input onto the screen. Pick an in node. Go in here, Arduino pin A0 digital, tell it it's an analog pin and call it pot. And say OK. Let's grab a screen element. We'll use another we'll use a chart this time, just because I've never used one and I want to see what it does. So chart implies that it's going to chart stuff. So let's just connect that to the chart. The pot's already configured. We want to put it into its own new UI. So let's call it, well, we'll pretend that that's a temperature sensor coming into it or something like that. So let's just call it temp. And that's added that. So we're going to call this one temperature. And group temp. So we're going to keep, let's just say, a week's worth of data. So old after 1 week. No data, or say no data, and we'll give it linear. Let's just leave those as all the defaults. I'm not sure how this works, but anyway, that should theoretically be enough. Let's get the pot and just wire it onto the Pi. Bit of wiring thing necessary to do this. Let me just hook it up and then I'll come back to you. Okay, I've hooked up the analog 0 input to a pot. I've just got it on the screen here so you can see. So this pot, and the pot is just strapped between 0 and 5 volts with the wiper of the pot going to analog 0. I've positioned the pot roughly in the middle right now. You can see here. All right. And if everything is good, we should be able to deploy this and it should start working. Let's just see. Successfully deployed. The page is probably going to do some kind of reboot or something like that, so we'll just wait for a second. As I said, quite often when you do I'm doing full deployments, which is causing oh, that's what I'm doing wrong. I'm doing full deployments in NodeRed. We'll talk about that in a minute. So this is now refresh the screen. So you can see now we've got the dimmer, the alarm, the servos that we had before. Now we have this temperature one. So here we go with temperature. Right now it's still saying no data. It is connected, but perhaps it's because it's not changing from when I started it. So let's see if this will do anything. I'm not sure if there's a sampling interval or anything like that. So let's add something else to this just that we know that works quickly. I've got no idea how the temperature node works. So we're going to add a gauge to this as well. Let's just drag it on the screen, drag a line to it. Go in here, tell it 0 to 1024 for the value that it's going to be. We'll put it in group temp. So it shows up there. We put it into the temp folder as well. Temperature. This would actually be the current temperature versus the aggregate temperature, so that's fine. So we'll say OK. What is this giving out? Analog pin. There's nothing else to configure here. Oh, maybe it doesn't like that. Because I've told it analog, maybe I just say 0 there. That might have been the issue. Let's just try that. Deploy that. Deploy. That's done. That's connected. Let's see if we get anything different. Oh, there we go. Look, it's working fine now. Now, of course, it's reading temperature, but of course, I've given it 0 to 1024, so that's pretty hot temperature. Let me just try and see if we can scale this. I think there is a component that allows me to do scaling in NodeRed, so let me just let that go. I'm going to stop the camera. But in here, there is a function that's called scale somewhere. I know Pete was mentioning it to me, and I found it on a previous occasion. Oh, range. Here we go. Not scale, but range. So we bring this in, and we'll delete these two connections, and we'll connect it into range. Move those across. Connect it to here, and let's just say input range is 0 to 1024, so we'll just say 0 to 1024, and the output represents, let's just say, minus 40 degrees to plus 100. And we'll round it up to the nearest integer, and we'll say scale temp. So we'll say OK. So that's now going to do that for us. Let's just make sure this gauge is set correctly, because now it's going to go from minus 40 to plus 100. I think the chart will take care of itself. And we'll just redeploy that. Okay, so we have a successful deployment. The email is staying in the same state because of what I was doing before. One of the reasons why I keep having an issue when I do a deploy is because up on deploy there are a number of different options, and when you do a full deploy it actually initiates a restart of NodeRed. So of course the NodeRed web pages and things are going to disconnect, and then it's going to restart the whole process, the service, the application again. So it could be down for quite a few seconds before it recovers and reloads and makes the web pages available again, loads up caches, etc., etc. What I should be doing here, because I'm only doing incremental changes, is really just doing either modified flows or modified nodes. So I'm just going to change that to say deploy modified flows and see if that improves things. Sorry, I should have mentioned that at the very beginning. I completely forgot about that. So anyway, it's now deployed, and we have these different sections that are now, we got 1, 2, 3, 4 tabs available to us now, and you can see them. So let's go back to the temperature one. Should be basically scaling nicely now. So it thinks it's around 25, 26 degrees because I'm basically kind of in the middle of the scale. So if I crank it down, right, as you can see, I'm going down to minus 40. It's showing in the scale. It's showing the just right here in the thing. It's showing the actual raw value, and then on the outside it is showing the actual ranging towards where it says minus 40. And then I'm cranking it back up again, and if we go up to the other end, it should go up towards plus 100. You can see there, so even changing colors. Don't know how I can modify the colors and things like that. I think right now it's just an automatic thing. I'm sure there probably is a way to modify how these work with some kind of style sheets or something, but you can see there now that that's quite happily making readings and taking different values from the analog input. And I really didn't do much at all to make that work. I just told it I want an analog input. It's analog 0, which don't put the A in like I did initially. And that's it working. So now we have a trend working as well. Now that data you could also feed to files and databases and stuff like that. Right now I just want to have it on the screen to show you how easy it is to do. Anyway, that pretty much completes the whole like NodeRed 101. I think I've done a little more than I was going to do, but I've shown you how to drive an LED, how to read a button, how to send an email from something happening on the Raspberry Pi, how to hook up an Arduino Uno to a Raspberry Pi to extend its capabilities to give you analog inputs and outputs quite easily. I mean, for $13 for an Arduino Uno or less, that's a pretty cheap way of getting a basic A to D, PWM output, servo control output, etc., etc. And you can put quite a few different servos on the Uno. So if you're doing robot control or something like that, you leave your Pi running NodeRed to do all of the math and control functions and everything else without actually touching the hardware. Maybe a few status LEDs or something else like that would be fine, and a few input buttons, but nothing high powered and nothing that's timing critical. And then leave all the timing critical stuff and offload that to the Arduino for functions like that. And that's quite a common practice. What we will look at in future videos is also disconnecting the Arduino from the control signal. So all of the sliders and everything else and the gauges we have on this display here, we can put these onto an MQTT server, which is basically an Internet of Things kind of hub where you can post values to an MQTT server, and then called publications, and then have other things subscribing, i.e. I'm saying, hey, I'm interested, like signing up for a newspaper or something like that. And then when anything comes in that matches what you subscribe to, because you can specify a filter, which is called a topic, it will get sent to you automatically. So that's really, really cool. Anyway, that's going to be in a different video. I don't want to complicate this one any more than I already have, because I've probably taken this near to an hour already. If you like it, give me a thumbs up. If you don't, well, don't, but I'm pretty sure you will like this if you're into doing I/O with the Raspberry Pi and Arduino Unos and things. I think this has been quite a comprehensive little intro into programming. And I think you'll agree that, what I've shown you here, I haven't done one bit of programming to create this. Even the very, very first one, you can see, because, this very first one we did, I actually pasted into the import clipboard folder. But really all that did was define these two objects, which you know already because I've done it down here, that you can just drag onto the screen. This is just a standard Arduino output node. So really the only thing that came in there was this little bit of functionality that just flip-flopped the value. So it's just going on, off, and that's really it. And that's pretty simple. So I just wanted to show you that that's another way that you can take other people's code and bring them into your own application if it is what you need it to do. Anyway, calling it quits now, and look out for the next one. What I'm going to do next, though, is I've got a few products to review, so it'll be a few days before I have some more NodeRed, Arduino, Raspberry Pi control stuff coming out. And I also want to figure out how to use I2C and SPI-Bus with the NodeRed so that we can actually have this as a web-based control panel for my power supply project. So that should be pretty awesome. And also it will teach you a lot more things about how to connect other devices to the Raspberry Pi and to the Arduino and other hardware devices. So anyway, see you again soon. Bye.